Good day everyone. This problem involves solving material balance without chemical reaction in the DWSIM software. The problem was taken from the book of Himmelblau and Riggs, Basic Principles and Calculations in Chemical Engineering 8th edition. For the overview, this problem recovers aromatic compounds by passing through the counter-current extractive scheme. So you can pause the video to read the problem. And these are the questions asked in the problem. So this is our figure and also a process flow diagram. As you can see, we have two entering streams, namely the sulfur dioxide with a mass flow rate of 3000 kilograms per hour and our feed, which is the catalytic reformate, having a mass flow rate of 1000 kilograms per hour. We also have two outlet streams, our product stream containing 0.15 kilograms SO2 per kilogram benzene, and our waste stream containing 0.25 kilogram per benzene per kilogram non-benzene. Since we don't have a non-benzene compound in our software, DWSIM, we can use other compounds as long as it is not an aromatic compound and not a benzene. It is due to the fact that this process flow will recover aromatic compounds. We can safely assume other compounds because this problem is a mass balance that does not involve any chemical reaction. We will be only using their masses. So now let's start solving this in DWSIM. So to start, let's open our DWSIM software and let's click on the new steady state simulation. Click on next. And now let's choose the compounds that we will use. First is benzene. Next is sulfur dioxide. And for our non-benzene compound, we will consider water. For our property packages, we will use Rolle's law. Now, we will clone the SI unit because in the problem it is stated that we will use kilograms per hour for mass flow rate. So we will do the same for time. Let's change it in terms of R. And as well as the molar flow rates. It's mole per hour. So click finished. Then, first let's auto-hide the bars and panels. Let's drag this down. Before anything else, disable the flowsheet calculator to avoid further errors. So now let's choose 3 compound separators. And let's name the first one as compound separator 1. Next is 2, and the other one is compound separator 3. Next, let's add mixer, 3 mixers. So click on the first one and let's rotate this to 270. The other one, let's rotate this to 90 degrees. So for our mixer 1, click on that and let's add 2 inlet streams and 1 outlet stream. So click on the outlet stream and let's rename that as D. Click on compound separator 1 and let's connect D as inlet stream. Click on the inlet stream, another inlet stream, and let's connect it to compound separator 2 as outlet stream 2. And click on the other inlet stream and let's rename it as catalytic reformate. And let's rotate this to 270. So now, let's click on compound separator 1. Then let's add outlet streams, 2 outlet streams as well as energy stream. So for our outlet stream 2, let's rename that as the waste stream. For the other outlet stream, let's rename that as A-1 and rotate to 180. So let's add a logical operator. So let's add a recycle block here and add A1 as the inlet stream. And let's create another outlet stream. And let's rename that as A-2. And let's rotate that to 90 degrees. Now let's arrange it first. Let's drag it. So now let's click on the mixer tool. Then create inlet streams. So the other inlet stream, let's connect A-2, and for the other inlet stream, we can connect that to compound separator 1. But first, let's create another outlet stream to be connected in compound separator 2. So we will rename that first to C. Then click on compound separator 2, then let's add C as our inlet stream. So click on compound separator 2 and let's create another outlet stream and as well as energy stream. And let's rename that the other outlet stream as B-1. Click enter. So now let's rotate that. So let's rotate it to 180 and let's drag it here. So let's add another recycle block and let's connect B-1 as the inlet stream. Also, we need to create another outlet stream and let's rename it as B-2. And let's rotate it to 90 degrees. So let's click on mixer 1 and let's add B-2 as the inlet stream 2. let's create another inlet stream. And let's rotate it first to 270, and let's rename it as the sulfur dioxide. So click on mixer 1 and let's add outlet stream to be connected to our compound separator 1. So let's connect it as inlet stream. Then click on compound separator 1 and let's create another outlet stream. So let's rename that as our product and rotate it to 270. So let's drag it here first. Now let's connect the MSCR14 as our outlet stream 2 in compound separator 1. And don't forget to add energy stream in our compound separator 1. So let's rearrange first. So now let's add specification blocks. 4 specification blocks. So for spec block 1, the source object is the compound separator 1. Our source property is benzene. And our target object is also the unit separator 1. And our target property is the non-benzene or the water. So now let's click on the compound separator 1 and let's specify that it is in mass flow. Also in units, it is in kilograms per hour. So as you can see, our outlet stream 1 is our A-1. For our spec block 2, our source object is compound separator 2. Our source property is benzene. Our target object is compound separator 2. And our target property is water. Now let's click on compound separator 2 and let's also specify that it is in mass flow. As well as the units, it's in kilograms per hour. Now let's click on spec 4 and our source object is compound separator 3. Our source property is benzene. Our target object is compound separator 3 and our target property is sulfur dioxide. Now let's click on compound separator 3 and let's also indicate that the benzene and the sulfur dioxide is in mass flow. As well as the units, it's in kilograms per hour. So now I guess it's settled. So let's click on the other spec block and our source object is our catalytic reformate, our source property is mass flow, our target object is compound separator 3, and our target property is benzene. Let's click on our compound separator 1, and let's go back to our problem first. So it is stated that it consists of 800 kilograms of benzene. So at point A, where our point A is our stream A, so let's input that in our compound separator 1. So we have 800 kilograms per hour benzene. Now for spec 1, so let's note that X is our benzene, and let's go back to our problem first. So it is stated that it contains 0.25 kilograms of non-benzene material. So if we will multiply this to 0.25, we will get the value of our non-benzene material in our target variable. So now let's click on the compound separator 2, and also let's go back to our problem. So in our compound separator 2, it states that it has 700 kilograms of benzene. So let's input that in our compound separator 2. So let's put 700 here for our benzene. So for our spec 3, let's input it. So X. So it is stated in the problem that it contains 0.07 kilograms of non-benzene material. So let's put that here. Let's multiply X by 0.07 to get the value for our non-benzene material. So now let's click on spec 4, and let's go back to our problem. So as you can see, our product stream contains 0.15 kilograms SO2 per kilogram benzene. So we need to multiply X by 0.15 to get the value of our SO2. So now in spec 2, since we want to know the value or the amount of benzene in the product, and we know that in the catalytic reformate, it consists of 70% by weight benzene and 30% non-benzene. So let's input X as our mass flow times 0.70. Then let's subtract it by X times 0.30, since we know that all the non-benzene is removed in the waste stream. So now let's go back to our diagram first. So as shown in the figure, in the waste stream, it consists of 0.25 kilograms benzene per kilogram non-benzene. So we will multiply this with 0.25. So this is the amount of benzene in the waste stream. So now let's click on our catalytic reformate, and let's specify that in the compound amount, it is mass fraction, or our basis is mass fraction. Now we have 0.70 for benzene, 0 for sulfur dioxide, and 0.30 for our non-benzene or water. So let's click accept changes and let's go to our stream conditions. So the amount of mass flow here is 1000 kilograms per hour. So now let's click on the sulfur dioxide stream. So our basis here is still mass fraction, and the amount here is pure sulfur, so 0 for benzene and 1 for sulfur and 0 for water. So click accept changes, and for our value in the mass flow, it's 3000 kilograms per hour. So let's check first the values in our spec blocks. So now let's turn on our flowsheet calculator and let's recalculate our spec blocks first. Okay, so let's solve the flowsheet. So now it is now solved, and let's click on the spec tool, and we have here 625 kilograms per hour. So in our compound separator 3, we did not get the same amount. Since we did not get the same amount, so let's recalculate it first. And actually I encountered a problem in spec block 2. So the energy balance did not converge because the amount here is very large, because the code here was multiplied by 3600. So we will divide our spec block 2 by 3600 to come up with 625 in our unit separator 3. So let's recalculate our spec blocks. And also the compound separator 3, as well as the whole flow sheet. So let's solve flow sheet. So now we have here our calculated value for our compound separator 3. So we have 625 for benzene. So now let's go back to our problem. So our questions here for letter A: how many kilograms of benzene are extracted per hour in the product stream? So to get our answer, let us click on the master property table, double click it, and let's rename it as question A. So let's click on the product and the mass flow mixture of benzene. So click on next. So we have here our answer for question number 1. So for letter B, so for B, here is our question. So now let's add another master property table. Let's double click and let's rename this as question B. Now let's select B and C. And the mass flow rate of benzene and the non-benzene, which is water. So let's click on their mass flow rate mixture of benzene and our water. So click on next. So we have here our answers for question B. I guess I made a mistake in clicking our master property table, so let's click again. Question B, so it's the mass flow. I think I clicked the wrong one, so okay, here, so it is the mass flow of our water. It's not the mass fraction. So now we have here our final answer. So the flow rate of D it is 875 benzene and 500 kilograms per hour non-benzene for a total of 1,375 kilograms. For C, we have 875 benzene and 249 non-benzene for a total of 1,124. So let's compare it to our manual solution here. So for question A, we got 625 in our manual solution, and also in our DWSIM we also got the same answer. For question B, we have a total of 1,375 for D, and for C we have a total of 1,124. So it's just the same with our manual solution. So I think we got the answer for our problem. I think we solved the problem. So thank you so much for listening.